we are continuing. This follows the evaluation of roots. Let us do a couple of examples. We have the roots of that equation are alpha and beta. You find an equation with integral coefficients whose roots are alpha out of beta, then beta out of alpha. It's a cheap one. So as part of our solution, we can have this equation. We have there 2x squared minus 7x plus 4 is equal to 0. Let us leave a 1 here, meaning we have x squared minus 7 out of 2x plus 2 is equal to 0. We can come, allow me say sum of all the roots, because I want to form a new quadratic equation whose roots are depicted by these two. So sum of all the roots is going to be my alpha plus beta. The sum of all the roots is a 7 out of 2, because you know that the general quadratic equation are written in the form of x squared minus sum of roots x plus product of roots. So it is a 7 out of 2. Then my product of roots, allow me use PDT, product of roots, which is alpha beta, product of roots alpha beta is going to be our 2. So allow me say the sum of new roots, the sum of new roots is alpha out of beta plus the beta out of alpha, such that if I have such a thing, I have alpha out of beta plus the beta out of alpha. Such a sum, I see this is going to be alpha squared plus beta squared and a common denominator which is alpha beta. So that we have done the evaluation of this guy as alpha plus beta squared, then minus twice alpha beta, then divided by alpha beta. But then alpha plus beta from our old roots is a 7 out of 2. This guy is squared minus twice alpha beta, which is twice times 2, which is a 4, divided by alpha beta, which is a 2. Then I see the upper part is going to be 49 out of what? Out of 4. 49 out of 4 minus a 16. I think that regresses to a what? That regresses to a 33 out of 4, then divided by 2, that is 33 out of an 8. And then my product of new roots, so it's going to be the product of this guy and this one. So I have alpha out of beta multiplied by beta out of alpha, and this regresses alpha beta. This gives us a 1. We've said that general quadratic equations are written in the form of x squared minus open bracket the sum of roots are x plus the product of roots is equal to 0. So I have my x squared minus 33 out of 8x, then plus 1 is equal to 0. We can multiply through by 8 so that we have it as 8 x squared minus 33 x plus 8 is equal to 0. As simple as that. Hope you've managed to follow. So our next question 2, we have that if alpha and beta, they are the roots of that equation, and find the equation whose roots are alpha cubed minus 1. This is alpha cubed minus 1 divided by alpha, and beta cubed minus 1 divided by beta. We do the same thing. So as part of our solution, we have there our equation that x squared minus px plus q is equal to 0. It means that if we are to come and get the sum of all the roots, which we can call alpha plus beta, these guys are equal to, it is a p here, it is this p. So we have here a p. Then the product of all the roots, PDT of all the roots which is alpha beta, it is the q. Now we are going to evaluate these roots so that we get forms of alpha plus beta and alpha beta, substitute in these guys, and then substitute into a quadratic equation. So if I can come and say sum of new roots, my sum of new roots, this is going to be alpha cubed minus 1 divided by alpha plus beta cubed minus 1 divided by beta, such that this regresses to a very simple thing. This times this times this, then over alpha beta. So I have beta into alpha cubed minus 1, then plus an alpha into beta cubed minus 1, then divided by alpha beta. If these guys multiply through, I'm getting my alpha cubed beta, then beta times 1 minus beta, then plus this and that, I get my alpha beta cubed, then minus alpha divided by alpha beta. I can collect like terms, this guy and that guy. Then I can factorize out an alpha beta in the two. So this and this, if I remove out alpha beta, when I'm bringing them together, I see an alpha squared, then plus a beta squared, then minus, if I factorize out a minus, remain with alpha plus beta, then divided by alpha beta. But then we've done the expansion of this, we've evaluated this guy, so you can have alpha beta into open brackets. This is the same as alpha plus beta squared minus a twice alpha beta, then minus the alpha plus beta initially divided by alpha beta. But then we know the meaning of this and this and this from our old roots. We know their meaning from our old roots. So we have alpha beta, which is a q, into alpha plus beta, which is now a p squared, minus twice alpha beta, it means minus 2q, then minus alpha plus beta, it means minus a p divided by a q, and I can leave it as that. Yeah, I can leave it as that because I see it can't simplify any further. Maybe if you are to split this so that this and this goes in, minus a p out of q, but you can leave it that one as your sum. So we can look at the product of new roots, the product of new roots. So my product of new roots is still the same thing. It's going to be alpha. It's going to be alpha cubed minus 1 divided by alpha, then multiplied by beta cubed minus 1 divided by beta, such that this goes to, I have this guy times that guy. I'm going to have the alpha cubed minus 1 into beta cubed minus 1, then divided by alpha beta. So if I multiply here, this times that, I see an alpha cubed beta cubed, then this times the other one, this is minus alpha cubed, then this times that minus a beta cubed, then plus 1 divided by alpha beta, such that I can have this as alpha beta, I factorize out the 3, then minus, I factorize out the minus, then alpha cubed plus the beta cubed, then plus 1 divided by alpha beta. So the only thing we are left to simplify is this guy, which we've already done. We've already done this guy as alpha plus beta cubed minus 3 is alpha beta into alpha plus beta. Yeah, so excuse me. So we are saying that we've evaluated this guy. So this goes to alpha beta cubed minus, this goes to an alpha plus beta, allow me put this cubed, then alpha plus beta cubed minus 3 is alpha beta into alpha plus beta, then allow me close up here, plus 1, then divided by alpha beta. So now we can come and substitute in the value of each. You know, alpha beta is a q, meaning you have here q cubed minus open brackets. I have here, this is p, meaning it is p cubed, p cubed here, then minus 3, alpha beta is a q, alpha plus beta is a p, then plus 1 divided by alpha beta, which is a q still, such that this can go to a q cubed minus a p cubed plus a thrice pq, then plus 1 divided by a q. It can simplify to such a simple thing, such that we know that general quadratic equations are written in the form of x squared minus the sum of roots into x plus the product of roots, product of roots is equal to 0. So this is my product of the root. Then I have x squared minus the sum. We've gotten our sum as q into that, so I have it as a q into p squared, minus 2q, I think, 2q, minus 2q minus p out of q, minus p out of q. This is I can put it in brackets and I say x, then plus the product of roots, which we are just from getting, which is a q cubed minus p cubed plus a 3pq plus 1 divided by a q is equal to 0. It looks like a bit long, but try to understand the flow. Yeah, when you understand the flow, they come out automatically on their own. Yeah, it is as simple as that. So remember to subscribe to our channel, like our videos, hit the notification button, and then when you are searching for work of your level, type in A level mathematics or A level algebra, A level this, such that you easily access the videos. Otherwise, don't still be selfish. Tell a friend that I found a good channel, there is this and this. It can help you out such that you pass together.